Hello guys and welcome back. So let's examine some of the problem we may have here. Let's see if I can produce something like that. Let's go back here to the subnetwork and drag the plank size. Okay, you can see in some situations we'll have this weird behavior happening to our planks. Okay, so let's take a look at what's going on in there. Let's turn on the primitive numbers so we can see now this one is plank 21. So I guess we can blast that out. Primitive 21. Okay, and we reverse delete non-selected. That's going to give us plank 21. And let's take a look at what's the problem of this guy. Okay, so if we go ahead and choose the points and grab that problematic one and hit T button to translate out, you can see, well, it's kind of like flattening the entire part. Okay, and then if we look for like a different one, let's see, 17. Okay, and let's grab this guy and also move it away. You can see it's having the same problem. Okay, so we need to find those problematic points. And the good thing is, if you just delete that point, then the whole geometry will be just fine, right? So the solution will be actually very easy, or it's basically finding that point and delete it. Okay, cool. So with that being said, there's one thing I kind of want to do before we move on, which is a fuse node to, you know what? Do we need fuse? Maybe we do. Just fuse it here for now. That's gonna remove some of the points that's irrelevant. Okay, and then we're gonna go for a for each primitive for loop. Just to simplify our process, we're gonna for loop over every primitive. If you check on single pass, you can see we're basically looping through every individual faces. Okay. Oh, and some of those are having like a redundant point. Don't know why it's in there. Oh, you know what? I think it is in there because let's take a look at that. I think it is in there because it is also a problematic point. Yeah, that's why you have another one in there. So yeah, let's deal with those things. Okay. So if you take a look at the problematic ones, it's basically having a point that's connected to the other 2 points and not having any angle, right? It's kind of like no angle here. So it's actually having this really unique characteristic. If we can use that to isolate those guys, we can delete. Okay, but before we do that though, I'm going to do a sort to sort the primitive, sort the points by vertex order. What that does is making the vertex go like, you can see, well, 0, and then 1, and 2, 3, 4, 5. It's gonna go through the order around the primitive, basically, or the face. After sorting, it's easy to find like what's the next point of a certain point. Like point 3, the next point is gonna be point 4, right? For point 2, the next point is point 3, and it's also easy to find the previous point. So for point 3, previous point is point 2. Point 2's previous point is point 1, and point 1's previous point is point 0. Okay, all right. So for every point, we just need to find the next point and the previous point. If, however, the current point's direction to the previous and to the next point are not having like a right angle, then they're basically the wrong ones, right? Because for the others, like 2, like 1 to 2, 2 to 3, that's right angle. 3, you can see right angle. 4, right? That's right angle. 5, 4 and 0, right? So only the ones that's not having a right angle will be the problematic ones. Or in other words, they're parallel, right? They're having the direction from the current point to the previous and next point. If those 2 directions are parallel, that means it's essentially the wrong one. Okay, so let's do that. I'm gonna go for a attribute angle here. I'm gonna say int previous point will be equals to, well, how do you get previous point? Well, you can do the current point number minus 1, but that could be problematic because the current point is, if that's 0, then minus 1 is -1. Right, that's not correct. So we have to do some if statement, and we can compose that all into this one line, because if we just use point number here equals 0, right? If it does equals to 0, then it's gonna be the number of points of the current geometry of the current geometry -1. If not, then we choose point number -1, right? So this is like a common practice to write down a if statement this way. So it's going to evaluate if the point number is 0. If it is 0, right, use the last point number, which is the number points -1, because number starts with 0. So you have this off by 1 differences. And here, this is point number -1 if it's not 0, right? And next point be equals to the point number, the current point number plus 1, but then you don't want it to reach beyond the maximum, so you just do a module operation with, again, the number points of the first geometry. Okay, now we have the previous and next point number, so we just need to get their location. Vector pre-point position be equals to point of the first input position attribute of pre is previous point. Okay, and then copy that, paste, and the next point position will be the next point in here. Now we got those two positions. Okay, and then we can say vector direction to previous point will be position minus previous point position. Okay, now we're asking for direction, so it's better to normalize it. Okay, actually that has to be previous position minus position. Okay, and then vector direction to next will be equals to normalize, and then next point position minus position. Okay, so that we're getting the the direction now to the previous to the next. Okay, now if those are the problematic ones, if I can go move it away, to the previous and to the next are going to be the same direction, right? For the problematic points. So all we have to do is, if those two are the same, so I'm going to say if the dot product of those two, because they're same direction, their dot product will be really big, like 1. But sometimes the decimal float numbers are not easy to compare. We just need to say if it's bigger than 0.98, a really big number here, almost 1, which it should be, then that's the problematic one. So we remove the point 0. And then for anyone who doesn't know what the dot product is, there's another video tutorial I did online. It's just reference to that. Remove point. It's current point actually, so point number will be the other argument. Run this. You can see now how we are basically deleting those two problematic points now. We call this guy fix error. Okay, cool. Now we can go here and say do not check single pass anymore, so it's gonna run through everyone. You can see now there's no problem anymore. And just to make sure that it's all good, go back here to the upper stream, and we can go change the plank size. You can see now no matter how we change the plank size, it's gonna be able to give us some really clean final result. Okay, let's take a look at the points. Yeah, hopefully we don't have any redundant points here. Anyway, yeah, so that's it for this video. And moving on to the next, we're going to try to add variations now to our plank. Okay, see you next time.